we have learned that if two exponential numbers with the same base are divided, then the exponents are subtracted, that is the powers are subtracted and the base remains the same. But what happens if the base is not the same? That is, if the bases are different but the exponents are the same. How do we simplify this expression? Let us see. We have 2 to the power 3 divided by 5 to the power 3. So we have these two exponential numbers. In this, the bases are different, but the powers are same. Now 2 to the power 3 is 2 multiplied 3 times. And 5 to the power 3 is 5 multiplied 3 times. So this is 5 multiplied 3 times. This is what we have. Now we have 3 2's and 3 5's. So for every 2, we have a 5 here. So we can group them together. That is, we can write them as 2 by 5 into 2 by 5 into 2 by 5. So we can write them in this manner. So this is what we have. Now this is 2 by 5 multiplied 3 times. 1, 2 and 3 times. 2 by 5 multiplied 3 times, which is equal to 2 by 5 whole to the power 3. So this is 2 by 5 raised to the power 3. In this exponential number, the base is 2 by 5 and the exponent is 3. So we see that if we divide two exponential numbers, their bases get divided and the exponent remains the same. So 2 cube by 5 cube is equal to 2 by 5 whole cube. We can generalize it in this manner. So if we have a to the power n divided by b to the power n, we see that these are two exponential numbers with different bases but same powers. So we can write it as a divided by b whole raised to the power n. So the division of these two exponential numbers gives us this exponential number. In this, the base are divided and the powers remain the same. Note that b cannot be equal to 0 because division by 0 is not possible. So b cannot be equal to 0 in this case. Now can you solve this question? We have 6 cube divided by 3 cube. So we have two exponential numbers being divided. They have different bases but same powers. So we can divide the bases. We can write it as 6 divided by 3 whole cube. Now 6 divided by 3 is equal to 2. And this 3 is there in the power. So 2 to the power 3 and 2 to the power 3 is 8. So we can write this as 8. So the solution to this problem is 8. Now it holds the other way round also. So you can come from here to here, but you can also go from here to here. That is, if you have an exponential number in this form, a divided by b whole to the power n, you can write it as a to the power n divided by b to the power n. That is, if you can express the base of an exponential number as a by b, then you raise the numerator to the power n and denominator to the power n. In this case as well, b cannot be equal to 0 because division by 0 is not possible. Now using this, we can simplify many calculations. Say you need to find the square of 45. Normally, you would write it as 45 into 45, multiply it to get the square of 45. But since you have learned this law now, you can apply it to make your calculations simpler and easier. 45 can be written as 90 by 2. So I can write this as 90 by 2 whole raised to the power 2. Now we can compare this 90 by 2 to a by b whole raised to the power n. We know that a by b to the power n is equal to a to the power n divided by b to the power n. So we take 90 as a and 2 as b. We get 90 to the power 2 divided by 2 to the power 2. This is what we have. Now 90 square is equal to 8100, 8100, and 2 square is equal to 4. So if you divide 8100 by 4, you will get the square of 45. Dividing 8100 by 4 is much simpler than multiplying 45 with itself. So you can apply this law to make your calculations easier. Now this is 2 by 5 whole raised to the power negative 3. That is, we have a rational number or a fractional number raised to a negative power. Recall that if we have an exponential number in which we have a negative power, we can write it as 1 by a to the power n. That is, a to the power negative n can be written as 1 by a to the power n. So I can write this as 1 divided by 2 by 5 to the power 3. This thing goes to the denominator and the sign of the exponent changes. So this is 1 divided by 2 by 5 whole raised to the power 3. So this is what we have. Now apply the law which we have learnt. This is a by b to the power 3. So I can write this as 1 divided by 2 to the power 3 divided by 5 to the power 3. We can write it in this manner. 1 by 2 to the power 3 divided by 5 to the power 3. Now this 5 to the power 3 goes to the numerator. So this is equal to 5 to the power 3 divided by 2 to the power 3. So this is what we have. Now again apply the law. A to the power n divided by b to the power n gives a by b whole to the power n. Using that, we can write 5 by 2 whole to the power 3. So this is the simplified form of this. If you observe carefully, you will find that 5 by 2 is the reciprocal of 2 by 5. Also, this negative 3 becomes plus 3. So the sign of the exponent changes and the base becomes reciprocal. So let us generalize this. We have a fraction a by b raised to the power negative exponent. So a by b raised to the power negative n. We can write it as 1 divided by a by b whole to the power n. We can write it in this manner. Now a by b whole to the power n is equal to a to the power n divided by b to the power n. So we can write it in this manner. Now this b to the power n goes to the numerator. So this becomes b to the power n divided by a to the power n. Now apply the law again. That is, we can write it as b by a whole to the power n. So this is b by a whole to the power n. Again we see that b by a is the reciprocal of a by b and negative n becomes positive n. So if we have an exponential number in which the base is a fraction and the exponent is a negative number, we can make the base the reciprocal of what it was and change the sign of the power. That is, a by b becomes b by a and negative n becomes n. This is the simplified form of this expression. Now using this, can you simplify this? This is negative 5 by 2 raised to the power negative 2. So let us simplify this. Since we have a negative power, we need to find the reciprocal of this. Reciprocal of negative 5 by 2 is equal to negative 2 by 5. So this is the reciprocal of this fraction, and negative 2 becomes 2. So this is what we have. Note that the sign of the exponent changes, but the sign of the base does not change. So we cannot change this negative sign. This remains as it is because we need to take the reciprocal of this fraction. So when we take the reciprocal, the negative sign remains as it is. Now what is 3 to the power 2 minus 2 to the power 2? Is it equal to 3 minus 2 whole to the power 2? That is it equal to 1 to the power 2? Well, no. This is incorrect. This does not hold. When we have a subtraction here, we cannot take this 2 in the power common. That is, if two exponentials with the same power but different bases are subtracted, we cannot subtract their bases. We can do it if we have division. So if we have 3 to the power 2 divided by 2 to the power 2, we can divide the bases and keep the power same, but we cannot do it for subtraction. It can be done only for division. So when two exponential numbers are divided, then there are two special cases. First is the bases are the same. If the bases are the same, then the exponents are subtracted and the base remains the same. Second is that the bases are not the same, but the exponents are the same. In this case, the bases are divided and the exponent remains the same. So this is what we have. So if two exponential numbers are divided, if the bases are same, the exponents will be subtracted. If the exponents are the same, the bases are divided. So do not confuse between these two cases. Just remember when you need to subtract and when you need to divide.